LangGraph implements human-in-the-loop patterns through interrupt-driven state persistence, enabling dynamic execution pauses that await external input before resuming workflow processing. This mechanism leverages checkpointing to maintain graph state across interruption points, with thread identifiers serving as persistent cursors for state management. The upcoming code demonstrates how to construct a nested graph architecture where a subgraph triggers an interrupt, pauses execution, and later resumes with provided input, all while maintaining state consistency through memory-based checkpointing. You'll see the initialization of both subgraph and parent graph structures, the interrupt handling mechanism, and the state inspection process that enables resumption of paused workflows.
From LangGraph, graph import start state graph. From LangGraph, checkpoint, memory import MemorySaver. From LangGraph, types import interrupt command. From typing extensions, import type dict. Class state type dict. foo, str. Hash subgraph. Def subgraph node 1 state. Value equals interrupt provide value. Return foo, state foo plus value. Subgraph builder equals state graph state. Subgraph builder, add node subgraph node 1. Subgraph builder, add edge start. Subgraph node 1. Subgraph equals subgraph builder, compile. Hash parent graph. Builder equals state graph state. Builder add node subgraph. Builder at edge start, node 1. Checkpointer equals MemorySaver. Graph equals builder. Compile checkpointer equals checkpointer. Configurable, threaded, 1. Graph invoke foo, config. Parent state equals graph, get state config. Subgraph state equals graph, get state config. Subgraphs equals true, task 0, state. Hash resume the subgraph. Graph invoke command resume equals bar, config.
This code demonstrates how to implement human-in-the-loop patterns using LangGraph's interrupt mechanism within a subgraph architecture. The pattern shows a subgraph that pauses execution mid-process to request external input, then resumes with the provided value. The implementation creates a nested graph structure where the parent graph contains a subgraph as a node. The subgraph's node uses interrupt to pause execution and request user input, which gets checkpointed via MemorySaver. The threaded in the config acts as a persistent cursor, allowing the system to resume exactly where it left off. When the user provides input via command resume equals bar, the interrupt call returns this value, allowing the subgraph to complete its operation. This approach enables dynamic interaction points in workflows that would otherwise run autonomously. The trade-off is that interrupts require persistent state management, which adds complexity, but provides flexibility for human oversight. The pattern is particularly useful for approval workflows, data validation, or any scenario requiring human judgment during automated processes. The checkpointing mechanism ensures resilience, as the system can recover from interruptions even after process restarts. Let's break it down.
From LangGraph, graph import start state graph.
Imports start and state graph from the LangGraph graph module, providing the starting point constant and the graph construction class for building stateful workflows.
From LangGraph, checkpoint, memory import MemorySaver.
Imports the MemorySaver class from LangGraph. Checkpoint, memory, which provides functionality for saving and restoring graph execution state to memory.
From LangGraph, types import interrupt command.
Imports the interrupt and command classes from the LangGraph types module, providing functionality to pause graph execution and resume it with external input.
From typing extensions, import type dict.
Imports typed dict from typing extensions for creating dictionary-like structures with type annotations.
Class state type dict.
Defines a state class that inherits from typed dict, creating a type-hinted dictionary structure for representing state data in a type-safe manner. This establishes a schema for state objects, where keys and value types will be explicitly declared as class attributes, enabling static type checking and IDE support for state management.
Def subgraph node 1 state. State.
Defines a function named subgraph node 1 that accepts a single parameter state of type state. The function signature indicates this is a node in a LangGraph workflow, designed to process or transform the graph's state when executed. The body is not shown, so only the declaration and parameter type are observable.
Value equals interrupt provide value.
Calls the interrupt function with the string provide value as its argument. This pauses the graph execution at this point and surfaces the message to the caller, waiting for external input before continuing. The value returned from this call will be whatever is provided when execution resumes.
Return foo. State foo plus value.
Returns a dictionary with a single key, foo, whose value is the sum of the current states, foo value, and the provided value parameter. This operation preserves all other state properties while updating only the foo field, effectively creating a new state object with the incremented value. The return dictionary maintains the same structure as the input state, but with the modified foo entry.
Subgraph builder equals state graph state.
Creates a state graph instance named Subgraph builder using the state class as its state type. This initializes a graph structure that will manage state transitions, where state defines the data model for the graph's execution state. The variable Subgraph builder now holds this graph instance, ready for defining nodes and edges.
Subgraph builder. Add node subgraph node 1.
Adds a node identified by subgraph node 1 to the subgraph being constructed by subgraph builder. This operation registers the node within the subgraph structure, making it available for connections and execution flow within that specific subgraph context. The line assumes subgraph builder is an active builder instance, and subgraph node 1 is a predefined node identifier or object.
Subgraph builder. Add edge start. Subgraph node 1.
Adds a directed edge from the start node to the node named subgraph node 1 in the graph being constructed by the subgraph builder. This establishes a connection where execution will flow from the graph's entry point to the specified node.
Subgraph equals subgraph builder. Compile.
Compiles the subgraph created by the subgraph builder into an executable graph. The compile method processes the graph structure, validates connections, and prepares it for execution, returning a compiled graph instance that can be invoked or further configured.
Builder equals state graph state.
Creates a state graph instance using the state class as its state schema. This initializes a new graph builder that will manage state transitions and node execution based on the defined state structure. The builder variable now holds this graph construction interface ready for adding nodes and edges.
Builder add node subgraph.
Adds a node named node 1 to the graph builder, where the node's implementation is provided by the subgraph object. This incorporates the entire subgraph as a single node in the parent graph, allowing hierarchical composition of graph structures. The node will be referenceable by the identifier node 1 in subsequent graph operations.
Builder at edge start, node 1.
Adds a directed edge from the start node to node 1 in the graph being constructed by the builder. This establishes that node 1 will be the first node executed when the graph runs, as execution begins at start and follows this edge.
Checkpointer equals MemorySaver.
Creates a checkpointer instance using the MemorySaver class, which handles persistence of graph execution state in memory. This object will be responsible for saving and restoring the graph's state during interrupt operations, allowing execution to pause and resume while maintaining context.
Graph equals builder. Compile checkpointer equals checkpointer.
Compiles the graph builder into an executable graph instance, configuring it with the specified checkpointer for state persistence. The resulting graph object can now be invoked to run the workflow, with the checkpointer handling save-restore operations for interruptible execution.
Configurable, threaded, 1.
Creates a configuration dictionary with a nested, configurable key containing a threaded set to 1. This establishes a persistent cursor for LangGraph's interrupt system, allowing the graph to resume from a specific checkpoint when execution continues.
Graph invoke foo, config.
Invokes the graph with an input dictionary containing an empty string for the key, foo, and passes a configuration object. This triggers graph execution with the specified input and configuration parameters, potentially including thread management or interrupt handling if configured in the config object. The exact behavior depends on the graph's implementation and the configuration provided.
Parent state equals graph, get state config.
Retrieves the current state of the graph execution using the provided configuration. The graphGetState method fetches the state associated with the config parameter, which likely contains thread-specific identifiers or other execution context. The result is stored in the parent state variable for subsequent use in the workflow.
Subgraph state equals graph, get state config. Subgraphs equals true, task 0, state.
Retrieves the state of the first task in the subgraph by calling getState on the graph object with the provided config and subgraphs equals true, then accesses the state property of the first task in the return tasks list. The result is stored in the variable subgraph state.
Graph invoke command resume equals bar, config.
Invokes the graph execution with a command object that resumes a previously interrupted process using the value bar. The config parameter provides execution configuration, which likely includes the threaded to identify the specific interrupted execution to resume. This line effectively continues a paused graph workflow by supplying the external input bar that the graph was waiting for. The implementation demonstrates LangGraph's interrupt-driven human-in-the-loop pattern through nested graph architecture. The subgraphs node uses interrupt to pause execution and request external input, while the parent graph orchestrates this as a single node. MemorySaver checkpointing preserves state across interruptions, with threaded acting as a persistent cursor for resumption. When the graph is invoked with command resume equals bar, the interrupt call returns this value, allowing the subgraph to complete its operation. This pattern enables dynamic interaction points in otherwise autonomous workflows, with the trade-off of added state management complexity for human oversight flexibility. The hierarchical composition shows how subgraphs can encapsulate interrupt logic while maintaining state consistency through the parent graph's checkpointing mechanism.
The interrupt vanishes, but the threaded whispers secrets to the checkpointer.